is Muhammad Nasser Abdul, and I'm here to give a online tutorial specifically on gravitational field. Gravitational field, I repeat. When we talk about gravitational field, let's talk about what we understand by force. Usually, there are two types of force. We have what we call contact force, and we have what we call the force field. Contact force and force field. The contact force is a force that's specifically the type of force that we encounter on daily basis. We encounter on a daily basis, such as a wheelbarrow. Pushing of wheelbarrow is referred as contact force. When we talk about the gravitational force field, in the force field, we talk about PG of the force field. We talk about gravitational force, the gravitational field or gravitational force. And the gravitational field or gravitational force is referred as the force exerted by the Earth on specific object or masses of objects that makes an object to, after it goes up, it will come down. That's what we call gravitational force. Based on this, we talked about, let's now explain what you understand by gravitational force. Gravitational force is refers as the force exerted by the Earth on an object that is being pulled upwards, and that causes that object to fall back as a result of the effect of gravitational force, as the case may be. For instance, we have the Earth. This Earth specifically mounts or exerted the force, which is called gravitational force, on you. The Earth exerted a gravitational force, which is a force on the moon. And that force is equal to 385,000 kilometer behind that object. Also, we have the sun. The sun also exerted a force on the Earth, and the force is 1.5 times 10 to the power 8 kilometer behind that specific force. So these are just a brief explanations of gravitational force. The gravitational force is the force exerted on the mass of an object that is causing that object to pull back after being pushed upward, respectively. And based on this, we talk about gravitational field. The gravitational field is referred to as a region. It refers as a region around the space where gravitational force is experienced by the mass of an object. This is an object A. So it's referred as a region around the space where effect of gravitational force is experienced or felt by the mass of that object, respectively. And based on that, it goes to the Isaac Newton. The Isaac Newton specifically talks about gravitational force law. And gravitational force law says that the force is directly proportional to the product of the masses. That's the two masses, M1 and M2. We call it equation 1. And is inversely proportional to the square of the distance between the two masses. We call it equation 1 too. Add equation 1 to equation 2, we have F is proportional to M1, M2 over R. This is R squared. We call it R squared. We call this equation 3. So based on this, we remove proportionality and make it to be what? K, which is the gravitational constant. We call it equation 4. Substitute specifically equation 4 in 3. We have F is equals to, then we have G, M1, M2 over R squared. That is the formula or the laws of gravitational force law. The gravitational field law or gravitational force law is referred as the force that is proportional to the product of the masses, M1, M2, and is inversely proportional to the square of the sum between them. We substitute to have this, and this gravitational force, the gravitational constant, the constant is 6.68 times 10 to the power minus 11 Newton per meter. Then we have the kilogram square. Newton per meter square and kilogram square. This is the effect, the SI unit of gravitational constants, respectively. So now let's talk about the relationship between the gravitational constant as well as acceleration to gravity. I'll come again. The relationship between gravitational constants, and acceleration due to gravity. Now, when we say F is equals to G m1 m2 over the r square. We call it here. Let's we call it here equation 1 respectively. And believe me, we have F is equals to mg. We call it equation what? Equation 2. So 2 in 1 we have F is equals to, what do you have here? F is equals to, we have what now? We have a G me m over re square is equals to mg. We call it equation 3. Automatically, 1m will cancel 1m. What do we have left? We have F is equals to, we have F is equals to what now? G me over r square. Since we want to relate equation, we want to relate gravitational G with respect to H. What we are going to do with respect to G, that's addition gas constant. We can now say equation what? 4. We have F is equals to G. We call it equation 5. Substitute. We have what now? G is equals to G me all over re square. This is the relationship between gravitational constant as well as acceleration due to gravity, as the case may be. And based on this, we now proceed. When we proceed, we specifically talks about escape velocity. And escape velocity, we have also formula, which is that escape velocity is defined as the quantity or maximum amount of the velocity that is required to pull off the mass of a specific or mass of any given substances from effect of gravitational force. I will repeat. Escape velocity is from the name escape. Escape velocity is refers to as the minimum or the maximum amount of velocity that is required to pull off of the masses of every given substances or object away from the effect of gravitational force, as the case may be. And based on this, we now see how we can do it. Now we have F is equals to, we have what? G. We have m over what? The r square. We call it equation 1. Then we have the F, which is from centripetal force. Centripetal force is equals to what now? mv squared over r. We call it what? Equation 2. We now substitute equation 2 in equation 1. We have what? mgv squared, right? Is equal over r is equals to what? G m over what? R squared. So what will happen? From here, the m, we cancel this m. We have what now? V squared over r is equals to G me all over what? R squared. One of these we cancel this 2. We have what now? V squared is equals to G me over r. So we square both sides. Square. The v, this cancel this. V is equals to square root of G me over r. This, as the case may be. So this also escape velocity from the speed. And we can also proceed and talk about another formula of how to derive an escape velocity. So the formula also is, we say what now? We say F is equals to Gm, we have Gm, talk about Gm E all over M, maximum M, E over what? Over R squared. We call it equation 1. So based on this, we now talk about, from here, we have the kinetic energy. We have the kinetic energy, or we can also make it to be like R is equals to Gm me over what? The R. Because this times this will still give the R squared. So from here, we can now say, okay, we have kinetic energy is equals to G me over what? R, equation 2. What is kinetic energy? Kinetic energy is equals to half mv squared. We call it equation 3. Substitute. We have what? Half mv squared is equals to G m over what? R. So automatically, this m is double m that is there. Yes, we have m, we cancel m. What do we have left? We have r v squared over 2 is equals to G me over what? R. Automatically now from here is we are going to we are going to, from here we cross multiply. When you cross multiply, we are going to have, when you cross multiply, you are going to have, when you cross multiply, we have this time is going to be 2GME is equals to V squared. We have R, and we make what sort of formula? We make M sort of formula. Yeah, you can make V sort of formula. From here, you can just do it directly. So we have let's look for make R sort of formula. From here, we make R sort of formula. We have divided by what R, divided by what R. R cancels R. The V squared is equals to 2GM over R square square. V squared, the V is equals to, we have 2GME over R. So that's the escape velocity, and this is where I will stop. Thank you so much.